All right, we're in text section 3.6, and I'm going to do number 49 with you, and we're going to put everything all together here. So we've been finding a little bit piecemeal. We found asymptotes from one set of problems, intercepts from another. So in this set of problems, we're going to find everything we can find and then graph the function. So some polynomial s of x is equal to 4x minus 8 divided by x minus 4 times x plus 1, which has already been factored for us, which is nice. But we're going to find intercepts, asymptotes. So to find the intercepts, I'm on page 301 in your text. Let's find the x-intercepts by determining the zeros of the numerator. So let's just do that first. So zeros of the numerator are going to be 4x minus 8 equals 0, 4x equals 8, x equals 2. So I'll keep a little record going up here. X-intercepts, and there's only one because it's a linear function. All right, what about the y-intercept? Well, the y-intercept is to set x to 0. So s of 0 equals 4 times 0 minus 8 divided by 0 minus 4, 0 plus 1. 0 minus 8 is negative 8. Let's see, 0 minus 4 is negative 4. 0 plus 1 is 1, so it's going to be a negative 4. Negative 8 divided by negative 4 is positive 2. And since it's the y-intercept, it's going to be 0, 2. Okay? So we found the intercepts. Let's go on to the asymptotes. I think I'll change pen color for that. So the asymptotes. So for the asymptotes, first of all, we have to look at the degree of our leading term. And that's going to mean everything for finding the asymptotes. So if the degree is greater, if n is greater than m, then there's no horizontal asymptote. Might be a slant asymptote that we'll look at the next video. If the degree equals the other degree, then we're going to divide the coefficients. And if n is less than m, which I believe is this case, then we're going to have an asymptote horizontal of y equals 0. So we've got a linear term here, and that's our n. And then we've got an x squared in the denominator, plus a 1x minus a 4x is going to be minus 3x minus 4. Now, that's not as important as here and here. We've got n is less than m, and going back to our interpretive table, n is less than m, y equals 0. All right, so that means we have a horizontal asymptote of y equals 0, and we're almost there. Let's find any vertical asymptotes. To find vertical asymptotes, I'm going to draw you down back to this table. Vertical asymptotes, number 3. Determine the zeros of the denominator. So, well, that's sweet because they've already factored it for us. So x minus 4 equals 0, therefore x is 4. X plus 1 equals 0, therefore x is negative 1. And those are our vertical asymptotes. So x equals 4, x equals negative 1. And that's not a negative 1. That's a negative 1. Okay, I'm going to draw a quick set of axes, and we're going to go ahead and plot what we've got. So here's the axes that I drew, and let's plot the points we've got. We've got an x-intercept of 2, 0. We've got a y-intercept of 0, 2. We've got a horizontal asymptote. It's actually the x-axis, which is the line of y equals 0. But let's go ahead and show that as an asymptote. Boom, boom. And then we've also got vertical asymptotes of x equals 4. So 1, 2, 3, 4. That looks about right. I like red for this. Yeah, it's red. Okay. Do some dash lines. And then we've got x equals negative 1. Okay. Great. So we've got some action going on in this graph, that's for sure. All right, so the next step is we need more points than what we have here. So I'm going to plot 1 point, crunch 1 point manually, and then I'm going to take you to your calculator and show you how you can use your table on your graphing calculator so that you don't have to like crunch every single number manually. But like, I'm real curious, what's going on here? I'll use a highlighter tool. What's going on here at 1? When x is 1, what's y? Because that's going to make a difference with my function. So when x is 1, I'm going to go back to this original function, s of 1. And we'd have 4 times 1 minus 8. And that's going to be divided by 1 minus 4 times, every time I see an x, I put in a 1. And why am I doing this? Because I want to see what that point is. So 4 minus 8 is a negative 4. 1 minus 4 is negative 3. 1 plus 1 is 2 over negative 6. So all of this to compute. When x is 1, y is negative divided by negative is positive 2/3. Okay. Now, we can only do that so long without getting completely bored. So 1 2/3. So this is where our graphing calculator is really handy. Okay, so I've taken the liberty of typing in my rational equation into the TI-83. Be careful with your parentheses. So my numerator in one set of parentheses, but then I have my denominator enclosed in 2. So the x minus 4 binomial in one set, the x plus 1 in another, and then opening and closing in a set of parentheses. And when I do that, I should have an accurate table of values. And that is a great tool for you if you don't want to just manually crunch all these numbers. And I don't right now. So 0, 2, there's our y-intercept. 2, 0 is our x-intercept. 1 2/3 we already got. But let's get a few more values here. Negative 1 is an error. There's an asymptote there. We know that. Let's do 3, negative 1. So 1 2 3, negative 1. And we're starting to get a feel for this function. I'd like to get when x is a negative 1/2 here, what's y? Because if y is high, then we're going to be falling from left to right. And we can do that. So I'm going to grab my graphing calculator. I'm going to change the intervals. So if I go into second table set, right here, this delta table, my input's moving by 1s, but I want it to move by 0.5. I want to see what that negative 0.5x is. So once I've changed that, I go back to second table, and sure enough, negative 1/2 is about 4.44444, so it's 4 4/9. So negative 1/2 goes to 1, 2, 3, 4, about right here. So I have a really good idea of what this function is doing in between my asymptotes. And it's doing something like this. Okay, that's all right. All right, now I want to see what's going on to the right-hand side of my asymptote at x equals 4 and what's going on to the left-hand side of my asymptote of x equals negative 1. So let's get a couple more points and on either side. So why don't we go over to what happens when x is 4.5. So 1, 2, 3, 4.5 is about here. And then y is about 3.63. So 1, 2, 3, it's about right here-ish. Let's get a couple more points there. What about when x is 5, y is 2? 1, 2, 3, 4, 5, y is 2. And then since we have an asymptote at y equals 0, I'm going to just be bold here. This line is going to be running something like this. Curve. Not a line, a curve. Okay, I'm happy there. And then let's look over to the left of negative 1. Let's get a couple points here. But actually, just to prove my point here, what happens if we looked at x at 8? It's going to be pretty close to 0, I think. X at 8 is about 2/3, so yeah, I mean, I'm trying to get this arrow going there. All right, so that looks good. Now let's get this left-hand side. It's a really pretty graph. All right, so we're going to jump back up here. And -2 maps to -2 and 2/3, -1, -2. -2 and 2/3 is going to be 1, 2, about here. Let's just do a couple more points there. What about -3/2 is -5-ish. So -3/2 is going to be, here's -1.5, 2, 3, 4, 5. 2, 3, 4. Okay. And then let's get -4. That'll give us a good curve. -4 maps to -1. 1, 2, 3, 4, about there. Okay, it's going to be tricky to do this. Oh, that was weird. It's really weird. Okay, we are going to come ever so close to this line, but we're never going to touch it, and we're going to be coming down. Ooh, that's not that great of a curve, but it's what I can give you right now on a glass pane. It's going to go down forever. So there we have it. So last step is, let's just talk about the domain and the range, and then let's justify this. I'll just justify it on the graphing calculator since we already have the function up. So the range, what are we doing on the y-axis? Well, the range is all reals. Look at this one function, or this one curve in the middle of our function, and so you can just say, hey, it's going to be all reals. But let's go ahead and talk about the domain. The domain x such that x cannot equal, and our asymptotes are -1 and 4. All right, I think that's it for the range and domain. Last move is, let's just justify this on our graphing calculator. Since we already have the function up, we've been using the table of values. Let's go to the graph. Boom, boom, boom. All right, I think looks like we got it. Here is an asymptote at -1. Here's an asymptote at 4. We've got a curve following our curve to the far left. In the middle, we've got something that's rising or falling from left to right. And then on the far right, we've got another curve that looks exactly like the curve we've got here. All right, that is it for this particular video.